Okay, today we have our last lesson. Yes, good morning. Today we have our last lesson, our last lecture, our last lecture. And tomorrow we will have last practice in our physics course. And it is necessary to remind that on our previous lecture we have solved differential equation of small free damped oscillations. Differential equation of small free damped oscillations. I will remind this solution, and I will remind equation. This equation can be written in this way: d2x by dt2 plus 2 beta dx by dt plus omega 0 to the power of 2 x is equal to 0. Is equal to 0. And the solution of this equation is x is equal to xv. Xv is a constant that may be found from initial conditions. So integration constant exponent of minus beta t multiplied by cosine of omega v t plus alpha where omega v is frequency of small free damped oscillations, and it is equal to square root of natural frequency to the power of 2 minus damping coefficient to the power of 2. Damping coefficient to the power of 2. And so it can be framed in red. This solution was obtained on our previous lecture. And on our previous lecture also was obtained differential equation of forced oscillations. Differential equation of forced oscillations. For example, for a simple oscillator, it can be written in this way. Second derivative of coordinate by time plus 2 beta dx by dt plus omega 0 to the power of 2 x, and this is equal to fm divided by divided by m cosine omega t. Cosine omega t. And you can see what is the difference between a differential equation of free damped oscillations and a differential equation of small forced oscillations. Here, in the right part is 0. Here, the right part of equation is 0. And here, we have fm cosine omega t divided by m. So this is the difference. This is the difference. The right part of equation is not equal to 0. Is not equal to 0. And what to do in this case? What to do in this case? In this case, we can try to find the solution. We can try to find the solution in this way. We can try to find the solution as sum of solution of sum of general solution of differential equation with part side that is equal to 0 plus partial solution of differential equation with non-zero right side. With non-zero right side. So let's try to do this. Let's try to do this. Let's make substitution. Let's make substitution and see what we will have from this. We have obtained that d. This is d2 x g d2xg by dt to the power of 2 plus 2 beta d x g divided by dxg by dt plus omega 0 to the power of 2 x g plus second derivative of xp by time second derivative plus 2 beta d xp dt and plus omega 0 to the power of 2 xp and this is equal to fm divided by m cosine omega t cosine omega t and this differential equation can be written in this way. d2 xg by dt2 plus 2 beta d xg by dt plus omega 0 to the power of 2xg, and this is equal to 0. This is equal to 0. And the second equation is d2xp d2xp by dt2 plus 2 beta dxp by dt and plus omega 0 to the power of 2xp, and this is equal to fm divided by m cosine omega t. Cosine omega t. Cosine omega t. Okay, so do you have any questions about this? And as you can see, this equation is the same as the equation in the red frame. This is the same. So it has the same solution. It has the same solution. So we can write that the solution is xg is equal to some xv multiplied by e to the power of minus beta t cosine omega v t plus alpha and omega v is equal to square root of omega 0 to the power of 2. Omega 0 is natural circular frequency minus damping coefficient beta. Minus damping coefficient. Okay, do you have any questions? Do you have any questions? No questions. Okay, so we have found the first part of the solution of the equation of forced small oscillations. Equation of forced small oscillations. So we can. I'll write this above. I'll write this in the top of the screen. So this is our first part of solution. This is our first part of solution. This is first part of solution, and it is necessary. It's necessary to find the second part. The second part can be found from this differential equation. And if xg is a general solution, we can find only partial solution. We can find any partial solution of this equation, and this will be enough. This will be enough. And according to the view of the right, according to the right part of this equation, let's try to find xp. Let's try to find xp as this. Let's try to find xp in this way. Xp is equal to xp is equal to a multiplied by cosine omega t plus b sinus omega t. Sinus omega t. And a and b to be found. A and b are constant that we need to find. So let's do this. Let's try to substitute this here. To do this substitution, we have to find two derivatives, first and second. First derivative is equal to minus omega a sinus omega t plus omega b cosine omega t Okay, what about second derivative? Second derivative will be xp dt 2 is equal to minus omega to the power of 2 a cosine omega t plus no, not plus, minus sorry, minus omega to the power of 2 b sinus omega t sinus omega t. So these are derivatives. So we can use them here. And we will obtain equality omega to the power of 2 a cosine omega t sine omega t minus omega to the power of 2 b sinus omega t sinus omega t minus 2 beta omega minus 2 beta omega minus 2 beta omega a sinus omega t plus 2 beta omega 2 beta omega b b cosine omega t omega t plus omega 0 to the power of 2 a cosine omega t and plus omega 0 to the power of 2 b sinus omega t, and this is equal to fm divided by m. fm divided by m. m divided by m cosine omega t. Cosine omega t. Okay, do you have any questions about this? Do you have any questions? Dear students, can you hear me?
Yes, teacher.
Yes, that's great. That's great. Okay. If there is no question, let's continue. Let's continue. Let's make some algebraic transformation. I mean that it is necessary to write cosine omega t and sinus omega t outside of the brackets. So I mean this. I mean this. I mean this. Oh, it will be uh, omega 0 to the power of 2 minus omega to the power of 2 a and plus 2 beta omega cosine omega t. It is necessary to close brackets, but not 2 beta omega b, then close bracket, cosine omega t, o, cosine omega t, and plus plus minus minus 2 beta omega a 2 beta omega a plus omega 0 to the power of 2 minus omega to the power of 2 b b here we have sinus omega t sinus omega t and this is equal to f m divided by m cosine omega t cosine omega t cosine omega t. So we have found that A and B we have to choose A and B according to this equation. According to this equation that is written in the last string. When that is written in the on the bottom of the screen. So I will clean some unnecessary things from the screen and then continue after this. So we have find that xp we have written this as a cosine omega t plus b sinus omega t. And our next step is to find a and b. From this equation. Find a and b from this equation. Okay, let's do this. We can see that this equation will be true when coefficients near cosine and near sinus are equal. So according to this, we can write that omega 0 to the power of 2 minus omega to the power of 2 multiplied by a plus 2 beta omega b and this must be equal to fm divided by m without cosine fm divided by m and here we have that minus 2 beta omega a plus omega 0 to the power of 2 minus omega to the power of 2 in parentheses b and this is equal to 0. This is equal to 0. So we have obtained a system of linear algebraic equations. System of linear algebraic equations. It can be solved with by Cramer's rule. Cramer's rule. Cramer's rule. I hope you remember this rule from linear algebra from your previous education, and according to this rule we have to find three determinants for this system of equation. First determinant is omega 0 to the power of 2 minus omega to the power of 2. 2 beta omega minus 2 beta omega 0 to the power of 2 minus omega to the power of 2 minus omega to the power of 2, and this determinant is equal to omega 0 minus omega to the power of 2 in brackets to the power of 2 plus 4 beta to the power of 2 omega to the power of 2 omega to the power of 2. And what about the second determinant will be delta A, and this is equal to Fm divided by M 0, Fm divided by M 0, 2 beta omega omega 0 quadrat omega 0 to the power of 2 minus omega to the power of 2 minus omega to the power of 2, and this will be Fm omega 0 to the power of 2 minus omega to the power of 2 divided by m. And the last determinant delta B is equal to omega 0 to the power of 2 minus omega to the power of 2 minus 2 beta omega and here the right side of this equation, Fm divided by M 0, and this is equal to 2 beta omega to beta omega Fm divided by m. Divided by m. Okay, do you have any questions about calculation of determinants of this system of linear equations? No questions. No questions. Okay, that's great. That's great. I will clean some unnecessary information. I will leave only results of calculation of determinants, and will use them, and I will use them to obtain the solution, to obtain A and B. To obtain A and B, to obtain A and B. To obtain A and B. To obtain A and B. So according to Cramer's rule for this system of linear algebraic equations, A is equal to delta A divided by delta, and this is equal to this will be F M Fm omega 0 So now I am making substitution. I use this here. Fm omega 0 to the power of 2 minus omega to the power of 2 Fm divided by m m, and this m is multiplied by omega 0 to the power of 2 minus omega to the power of 2, and this to the power of 2 plus 4 beta to the power of 2 omega to the power of 2. Omega to the power of 2. And the next, B is equal to delta B according to Cramer's rule, divided by delta, and this will be 2 beta omega Fm divided by m omega 0 to the power of 2 minus omega to the power of 2 plus 4 beta to the power of 2 omega to the power of 2. Okay, so we have found these coefficients a and b. We have found these coefficients of a and b. So we have already had the solution of our differential equations of small free of small forced oscillations but this form of solution is not quite useful. This is not quite useful. So it is necessary to simplify this. It is necessary to simplify this. It is necessary to make some algebraic transformation to make our solution more useful. To do this, I will clean some unnecessary information from the screen. I will clean some unnecessary information. So I will leave only A and B. We need them in future. And I will erase this. So we have obtained the solution, partial solution xp in this way, where a and b are constant. They depends on parameters of oscillating system. They depend on parameters of oscillating system. And but this form is not quite useful for us. So it is necessary to make some changes. It is necessary to make some transformations in this solution. So let's do this. I will multiply and divide. Divide this expression by square root of a to the power of 2 plus b to the power of 2 plus b to the power of 2. Multiple and divide. And this is a divided by square root of a to the power of 2 plus b to the power of 2. Cosine omega t plus b divided by square root of a to the power of 2 plus b to the power of 2. Sinus omega t. Sinus omega t. Sinus omega t. And what to do with this? What to do with this? We can make some sinations. We can use these sinations. Xm is equal to square root of a to the power of 2 plus b to the power of 2. Cosine of some phi 0 is equal to a divided by square root of a to the power of 2 plus b to the power of 2 and sinus of phi 0 is equal to b divided by square root of a to the power of 2 plus b to the power of 2. And from here we can see why do we need this square root? Why do we need this square root in denominator? Because according to the trigonometric rules, cosine to the power of 2 phi 0 plus sinus to the power of 2 phi 0, this must be equal to 1. This must be equal to 1. Let's check this. Let's check if it is true. A to the power of 2 plus b to the power of 2 plus b to the power of 2 divided by a to the power of 2 plus b to the power of 2. And this is a to the power of 2 plus b to the power of 2, a to the power of 2 plus b to the power of 2. So this will be equal to 1. This will be equal to 1. So our oscillation is so everything is okay. Everything is okay because we have obtained unit in the right side. Okay, do you have any questions about this? No questions. No questions. Okay, if there is no questions, I will clean some place on the screen, and we can use this here. According to this, we have that this is equal to xm and cosine phi 0 cosine omega t plus sinus phi 0 sinus omega t sinus phi 0 sinus omega t and this can be transformed by well-known trigonometric formula. This will be xm multiplied by cosine of omega t minus phi 0 minus phi 0 sine omega t minus phi 0. And this form of partial solution, this form is much more useful than it was before. Much more useful than it was before. So it is necessary to leave only this last form of the solution, because this is the most useful. This is the most useful for our case. Okay, so I will clean some unnecessary information. I will clean some unnecessary information from the screen. Clean some unnecessary information, and the last step. The last step is to find some explicit expression, explicit formula for xm and phi 0. It's necessary to find explicit formula for xm and xm and phi 0. So xm is equal to square root of a to the power of 2 plus b to the power of 2. A to the power of 2 plus b to the power of 2. And this will be, let's use I can make some arrow for explanation, and this will be omega 0 to the power of 2 minus omega to the power of 2 in brackets f m to the power of 2 divided by m to the power of 2 omega 0 to the power of 2 minus omega to the power of 2, and close bracket, to the power of 2 plus 4 beta to the power of 2 omega to the power of 2, and here to the power of 2 to the power of 2 plus 4 beta to the power of 2 omega to the power of 2 fm to the power of 2 divided by m to the power of 2 omega 0 to the power of 2 minus omega to the power of 2 to the power of 2 plus 4 beta omega to the power of 2, close bracket, to the power of 2. Okay, and do you have any questions about this? Do you have any question? it is necessary to write this a little bit better. And this all is under the square root. Is under the square root. Okay, let's make some algebraic transformation. Algebraic transformation. Let's make some algebraic transformations. This value we have the same coefficient in both terms. The same coefficient fm divided by m and to the power of 2. So this can be written. This can be written outside of the square root, or maybe let's write this. Let's write this with this coefficient. So we have fm to the power of 2 omega 0 to the power of 2 minus omega to the power of 2 to the power of 2 minus 4 beta to the power of 2 omega to the power of 2 close bracket divided by m to the power of 2 to the power of 2 omega 0 to the power of 2 minus omega to the power of 2 but y minus is plus. Here we have plus, of course, 4 beta to the power of 2 omega to the power of 2 omega to the power of 2 close bracket to the power of 2 and under the square root under the square root and we can make some simplifying some simplifications. So here we have fm divided by m modulus and 1 divided by square root of omega 0 to the power of 2 minus omega to the power of 2 plus 4 beta omega to the power of 2 4 beta omega and fm and m are non-negative values and moreover they are positive. fm is amplitude, so it is positive, and m is mass, and mass is always positive value. So they can be written without modulus. So this is equal to omega 0 to the power of 2 minus omega to the power of 2 to the power of 2 plus 4 beta to the power of 2 to the power of 2 omega to the power of 2 omega to the power of 2 omega to the power of 2. Okay, do you have any questions? Do you have any questions about this? This is the amplitude of forced small oscillations. Amplitude of forced small oscillations. So okay, I will clean some unnecessary information from the screen. I will clean some unnecessary information. So we have found xm. We have found xm. We have found xm. We have found xm. Explicit formula to find xm. And the next step is to find phi 0. Let's try to do this. Let's try to do this. Let's try to find phi 0. Phi 0. The best way to do this is to write tangent of phi 0. This is the same as sinus of phi 0 divided by cosine of phi 0 divided by cosine of phi 0 divided by cosine of phi 0, and this is equal to let's use this formula. Let's use this formula. So this will be b divided by square root of a to the power of 2 plus b to the power of 2, and divided by a, and the square root of a to the power of 2 plus b to the power of 2 to the power of 2. And this can be written as b divided by a. B divided by a. And from here, I can write that this will be how to write this beta. How to write this beta. How to make this substitution. And in this way it will be quite better. It will be quite better. So let's make substitution. So fm Fm omega 0 to the power of 2 minus omega to the power of 2 omega to the power of 2 divided by m divided by m omega 0 to the power of 2 minus omega to the power of 2 and to the power of 2 plus 4 beta quadrat omega 4 beta to the power of 2 beta squared omega squared beta squared omega squared and divided by sorry, b divided by a, not a divided by b. So it is necessary to fix a mistake. To fix 2 beta omega f m. 2 beta omega fm and divided by fm omega 0 to the power of 2 minus omega to the power of 2 divided by divided by m omega 0 to the power of 2 minus omega to the power of 2 close bracket plus 4 beta omega and this is equal to this is equal to this is equal to so we can one more mistake, this is not omega, this is m, okay, and it can be written as 2 beta omega 2 beta omega divided by omega 0 to the power of 2 minus minus omega to the power of 2 to the power of 2. Okay, do you have any questions? Do you have any questions? Do you have any questions about this? No questions. Okay, that's great. I hope everything is clear because the material is this information is difficult to understand. This information is difficult to understand. A lot of algebraic transformation, a lot of formula, and now Now I will leave only the result of this. So we have found both parts. We have found both parts, and this we don't need this A and B anymore. Okay, so have we have we have found that the solution of this differential equation can be written as sum of xg plus xp, where xg where xg is equal to this, and xp is equal to this. Xp is equal to this, and this is the solution of the equation of small forced oscillations. This is the solution. This is the solution of this equation. This is the solution. We have obtained this, and we can write that this. So we have the solution of our differential equation. Differential equation of forced small oscillations. Okay, and what about what about electrical oscillations? As you can remember from our previous lecture, for electrical oscillations, we have very similar differential equation. For electric oscillations, we have differential equations. d2q divided by dt to the power of 2 plus 2 beta dq by dt plus omega 0 to the power of 2 q, and this is equal to the amplitude of electromotive force divided by not m, inductance. Here we have inductance cosine omega t, where damping coefficient beta is equal to resistance divided by 2L, where L is inductance, and natural angular frequency is equal to 1 divided by square root of inductance and capacitance. And the solution is very similar. The solution is Q is equal to Q V multiplied by e to the power of minus beta t minus beta t cosine of omega v t plus alpha plus q m cosine omega t minus phi 0 minus phi 0 where omega v is equal to the square root of omega 0 to the power of 2 minus beta to the power of 2 and the amplitude of the charge is m divided by L square root of omega 0 to the power of 2 minus omega to the power of 2 plus 4 beta to the power of 2 omega to the power of 2 omega to the power of 2 and tangent of phi tangent of phi 0 is equal to 2 beta omega omega 0 to the power of 2 minus omega to the power of 2 omega to the power of 2. Okay, do you have any questions about this? Do you have any questions? Do you have any questions? What is necessary to say? What is necessary to say? Here we have the solution. Solution of small forced oscillations, and especially for mechanical oscillations and for electrical oscillations. For mechanical and for electrical oscillations. What can we say about this? What can we say about these solutions? About these solutions. Here we can see that solution consists of two parts. This part and respectively this part is harmonic oscillations. But this term or part and respectively this part this part. It looks like damped oscillations. So this part is a dissipative function. And especially for electrical oscillations, this function dissipates very quickly, and after only after a little only after a little time uh, we can we can suggest we can put that the solution is just qm multiplied by cosine of omega t minus phi 0, because then the same situation or similar situation with mechanical oscillations, because this part this part dissipates very quickly. So it is it vanishes very quickly, and because of this after just a little time we can write the solution only as this, and and to find qm and phi 0 according to the formula that are written above. Okay, do you have any questions? Do you have any questions? Okay, so it was our last lecture, and tomorrow we will have our last practice, and we will do some exercises, for some exercises to for better understanding of electrical oscillations. So I hope to meet you tomorrow.